Hello, and welcome to today's WJE webinar. My name is Liz Pimper, and I'll be your moderator for this webinar, Parking Structure Maintenance, Get Ahead of Deterioration. During the next hour, WJE engineers James Donnelly, Tracy Naso, and Andrew Lobbestael will discuss common causes of parking structure deterioration, implications of recent research into typical deterioration, expected parking structure maintenance costs, and how to extend the service life of your parking structures. And I will now turn it over to Tracy to get started. Tracy?
Thank you, Liz. Good morning, everybody. My name is Tracy Naso. I'm a structural engineer. I split my time right now between our headquarters in Northbrook and our branch office in Honolulu, Hawaii. So I'm actually saying good morning from Hawaii today. But thank you, everybody, for coming in. This is a very popular topic. It's one that we get a lot of client questions about. I think it's reflected. We've had actually a very high registration and good response whenever this got solicited. Basically, why do we get so many questions about this? Parking garages are one of those things. They're not particularly glamorous. They're kind of there. People pull in and pull out and immediately go do something else, and they don't get a lot of attention. That changes when something goes wrong. Oftentimes we'll get called after, for instance, a piece of concrete falls and breaks somebody's windshield, and all of a sudden it's a crisis situation. And so we're putting this presentation together and talking to you guys, trying to give you some tools to be able to head off a situation like that. It's one of those things that sort of doesn't get neglected, but really doesn't get a lot of attention when just a little bit of love over time can prevent a lot of very urgent situations from occurring. So going into the presentation, we want to make sure that coming out of this, you're going to be able to identify common causes of parking structure deterioration. So we'll go through some examples of that. We also need to be able to explain the implications of recent research into typical deterioration and use that as tools for planning, understanding the costs and importance of maintaining parking structures, and then also giving you some tools to be able to budget more effectively, both for maintenance and for periodic repair projects. So today's presentation, we're going to go through some of those common causes of deterioration, but also discuss theoretical deterioration curves. There's been a lot of research into this in the last several years as people have observed parking structures age and how they tend to go through their life cycle. Discuss some typical repair costs. I know they vary significantly across the country, but there are some trends that we'll be able to help highlight. And then also discuss some proposed maintenance schedules and go through some case studies of some extremes, both good cases and bad cases that we've seen. So getting into it, like I said, a lot of times we get called and there's an urgent matter where something has happened. So I'm going to go through a few different scenarios that we often see to kind of show you guys what can happen and how it can happen and how it can get to that point. So one really basic concept that I want to talk about real fast is corrosion. So there's concrete involved in almost some aspect of every parking garage that's available in the country. Essentially, this is the driving force of most of the deterioration and issues that we see. So understanding kind of this idea of, there's embedded steel or there's open steel, it's going to deteriorate through a corrosion mechanism. In areas of the country where we either have applied de-icing salts that introduce chlorides into the system, or in coastal areas where we have atmospheric chlorides, that chloride can actually greatly accelerate this. So parking structures being open and also being subject to vehicles that bring in materials off the street, it actually is a very, very aggressive environment. One big point that I want to make that you'll see this theme kind of come up through the rest of the presentation is in order for corrosion to occur, you really need three elements. You need a susceptible material, you need moisture, and you need oxygen. So just talking through real quick, you can kind of see in this graphic, one of the big things that we see is an electrochemical reaction, we'll call it galvanic corrosion, where you get different electrical potentials in different parts of your structure. And if those two parts are embedded electrically, so in this case, in the illustration, you can get two rebar mats and a slab of concrete, and they're connected by the wire ties. you can actually get a very aggressive corrosion mechanism that can cause a lot of damage whenever rust forms. Case in point. This is an example of an area where a lot of delamination was ignored for quite a period of time. We usually see this most obviously at top steel when it reinforces around columns and over beams and floor systems. In this particular case, they could see a little bit of pothole whenever they walked in, but after a sounding survey, we could actually hear that there was a horizontal crack just below the surface. And it was severe enough that once we lifted that chunk of concrete, you can see there was significant deterioration of the reinforcing steel. And obviously, this has structural implications, as the reinforcing steel, particularly in concrete garages, is your main load carrying capacity. So whenever we start having significant deterioration and loss of that system, it can accelerate a repair necessity very quickly. In this photo, you can see that same pattern of delaminations being around columns. You can see the orange marks that are painted on the floor. Those actually outline areas of unsound concrete. So in this photo, you're seeing upwards over 5% of the deck is probably affected by this. Even though we have a lot of corrosion related to applied de-icing salts and surface applied water, there are some other mechanisms that also come into play. So as concrete ages, it's subject to a chemical process called carbonation. It basically is where atmospheric carbon dioxide reacts with elements in the cement matrix. It actually lowers the pH of the concrete. And this is important because in highly alkaline concrete, it actually forms a protective barrier around the reinforcing steel that prolongs and protects that steel from corrosion. As we lose that barrier, as the carbonation process lowers the pH over time, even in structures that otherwise are well protected, we can actually get corrosion starting just from atmospheric moisture. So this comes into play when you get structures that are usually anywhere between 25 and 50 years old. So it is not something that we usually see in a new construction. It is accelerated in instances where you have low quality concrete or lightweight concrete, and it becomes more critical whenever you have structures that have relatively low cover. So a lot of buildings that are constructed now under modern codes can have maybe an inch or even 2 inches before you reach the level of the steel. So it provides atmospheric protection. In older structures, like those built maybe the mid-1980s, you can see cover as low as 3/4 of an inch. So you can see some of the implications. This is important because whenever we're developing strategies, particularly preventative maintenance, we may start talking about protective coating because it can either prevent carbonation in the first place or it can cut off the moisture source. And it's one of those 3 elements that drives corrosion. In northern climates, and particularly the Midwest, we see a lot of freeze-thaw damage and deterioration. This essentially happens when you have concrete that's exposed to moisture. It becomes saturated with water. That water freezes, and then it destroys the concrete matrix. So that photo on the right, that's actually one of my projects where we came in and found kind of a funky sounding spot in the concrete, and because we're curious individuals, started beating on it with a hammer, as normal people would do. And suddenly we had a hole that was about 2 inches deep in the deck. Basically, the freeze-thaw deterioration was so severe that it had just softened the concrete. And keep in mind, this is the concrete that normally you'd be driving on, to the point where we could remove it by hand. So on the left, you can see a microscopic view of freeze-thaw damaged concrete that kind of illustrates this mechanism a little more cleanly than just a hole in the deck, where you've got small fractures that develop in that concrete from the tensile forces of the ice that forms in the saturated concrete and just destroys that matrix. In extreme situations, you can get a combination of freeze-thaw deterioration and accelerated corrosion. So a lot of times whenever you're getting a sufficient amount of moisture to trigger a freeze-thaw situation, it's enough that you're also getting severe corrosion, because again, that's one of those three components. This particular very dramatic garage, it's a precast structure that hollow core plank was sitting on that bearing ledge that has been highlighted by the orange arrow. There was enough deterioration on that ledge because there was an open joint at the end of the precast that it actually led to this failure. We can't talk about moisture enough. In this particular instance, we have an expansion joint seal on the left that actually looks pretty like it's in pretty good condition on the top surface. In this particular instance, anytime you let moisture in, it doesn't matter if it's the Midwest or a coastal region or any place else that it rains, you can get very, very confined deterioration. So here you see something that's relatively minor on the top surface on the left, but on the right, you can see where there's paint failing from moisture penetration, there's cracking from corrosion, and there's the laminated concrete. Open cracks is another seemingly innocent, normal occurrence in concrete because all concrete cracks. The issue is that whenever we leave it untreated and unsealed, water gets in and you get a very, again, concentrated moisture level right beneath it. So in this instance, you have a relatively small crack that was not sealed on the top surface of a garage. For perspective, since we're going to get into costs in a few minutes, it would have cost a couple $100 to seal this crack. It's a relatively low cost maintenance item. The photo on the right is the condition of the concrete immediately below this crack. Essentially, we have severe section loss in the reinforcing steel and concrete falling that resulted from that long-term moisture ingress. The actual repair, instead of being on the order of a couple $100, was much higher, on the order of several $1,000s, because it became a structural issue instead of just a water leakage issue. Precast structures kind of have some unique needs, mainly because there are literally miles of joints that need to be sealed in order to protect the structure and make sure that it's sound in the entire precast garage. The special implication of the precast structures is that because it's delivered and erected in discrete pieces, we have to weld everything together in the field so that it becomes one whole structure in the end. The result of that is we have hundreds of discrete weld points that are susceptible to deterioration if exposed to moisture. In newer structures, they have changed these connections from being regular mild steel to being stainless, which has addressed some of those issues. But it's definitely still worrisome that there's a small leak that can cause a little bit of deterioration at one discrete point along the joint. And in the end, if that continues long enough, if we get any kind of distress or deterioration in that connection, the structural implications have to be addressed. We start to lose continuity in our structure, but also it can allow a joint to have excessive movement, and future maintenance repairs, as we're trying to seal those joints, can actually be inhibited because you shorten the life cycle of your sealant in those situations. There are some steel structures still hanging out in the country. There's several in the Midwest. I know that they're still pretty popular in the Northeast areas. The susceptible portion of steel structures in particular is actually maintaining the protective coating. Even a good quality, high level industrial type coating only has a service life of about 20 to 25 years. This is all very consistent with steel bridges that you see when you're driving down the highway. A lot of times it's very onerous to come in and start doing paint maintenance repairs. You know, it's not fun. It at least makes everything look a little bit brighter and cleaner at the time, but it is very expensive to do that. But the implication of not is that you can get significant structural loss and significant steel repairs required over time. So the two illustrations that I'm showing you right now, the one on the left, you'll see some bright spots in the middle of an H-shaped column. That's actually not paint. That is the deck on the other side of the column because there's full section loss through that web. There's actually holes, so you can stick your fingers through the column. On the right, that's a photo of a connection that is directly underneath an expansion joint seal that had been leaking. So two things happening here. We could have stopped the water from the top surface had there been a little more forethought. But on this particular connection, it's actually cracked. So this became a critical situation where shoring was required in order to continue use of the structure. One easy thing that we see that we greatly encourage owners to stay on top of is plumbing and drainage. A lot of times we'll walk in and we'll start seeing water accumulating. And our initial reaction is, oh geez, that's where we're gonna have some problems because we had a lot of moisture exposure, which means that there's probably salts also involved because those are carried by water and it's gonna be concentrated near the drains. On the other hand, this is a very easy thing from a maintenance standpoint to be able to address. So there are some very, very simple, low-cost, easy methods and approaches that can be used to help preserve the life of your structure. And we'll go into that in more detail in a little bit. So with that, I'm going to hand off the presentation to Andrew.
Thank you, Tracy. I'm Andrew Lobbestael out of WJE's Detroit office. In this portion of the presentation, my portion, it comes from trying to answer one of my clients' questions. They wanted to know how much, in general, they should be planning to spend on their parking structures. So I'll discuss a few specific things and then hopefully kind of package it together and put a bow on it and provide that answer to that client. First off, I'm going to discuss theoretical deterioration curves. And this diagram here is kind of the classic deterioration curve for parking structures. It's the tool that consultants have used for a long time now to try and convince owners and property managers to spend money on their parking structures. In the X direction, we have time, and then in the Y direction, we have deterioration, which is directly related to repair costs. And the main concept is that repair costs tend to increase exponentially over time. You can see from A to B to C to D. And at some point, if the deterioration is allowed to continue, then the structure will be in a condition where it should be demolished, and hopefully that occurs prior to a structural failure. Then the next concept with the theoretical deterioration curves is relative repair costs. And the idea here is that earlier interventions cost less and have a more significant impact on extending the service life of the structure as compared to a later intervention. You consider the two structures here. Structure A is in blue, structure B is in red. For structure B, you'll spend more money to restore the parking structure. You can see the height difference from B to B.1 is greater than from A to A.1. But also note that the slope of the deterioration curve after the repair project is steeper than in parking structure A, where you did the earlier intervention. And then I'll take this concept one step further. Clearly, there's different levels of repair projects that you could undertake. First off, let's consider the crummy repair project, shown by this red line. We'll use El Cheapo bag mix, marginal surface prep, no chipping around the bars, and let's forget about a rebar coating, and lastly, no sandblasting. Seriously though, we do know that these type of repairs do occur, and there's a cost associated with them. But you'll notice, at least in this theoretical example here, that it hardly changes the slope or the rate of the deterioration, and thereby it doesn't have a significant impact on the service life of the parking structure. Or you could do high quality repairs that include durability improvements. That's represented by this blue line. Yes, it's going to cost more, but the idea is that when you implement durability improvements, you decrease the rate of deterioration, and that's where you get the extension in the service life. And examples of durability improvements are applying clear penetrating sealers, installing traffic coatings, replacing uncoated bars with epoxy coated bars, adding supplemental drains to address areas of ponding water, or even using galvanic anodes within your repair areas to protect the concrete and embedded reinforcing steel outside of your repair area. And then between the red and blue lines, I show a project here where you would do high quality repairs, but you would not implement durability improvements. This might be a concrete repair project where you don't have enough money to put the traffic coating on, but you still want to do high quality repairs. So I often work for property managers, and I understand their struggles. They have to go to owners with their hands out asking for money for the lowly parking structure that isn't bringing in any revenue. And it can be a hard sell to, one, convince them to spend the money early before there's widespread obvious deterioration, or also that it's worth spending more money to implement the durability improvements. So hopefully in this next part I can kind of give the property managers and owners the information to make an informed decision. So just for reference, I included information on the cost for a new parking structure. This we can keep as a point of comparison when we are considering the cost for parking structure repairs. For 2019, it costs about $65 a square foot for the kind of vanilla parking structure. It could be more or less depending on the complexity and location of the parking structure. There's a premium in cities like LA and Philadelphia, and you might catch a break in Atlanta and Phoenix. And don't forget to add in soft costs. Generally, they're 15 to 20%. So you add that on top of the $65 a square foot. And I think it's worth noting to, that you don't want to fall into the trap that a new parking structure doesn't require maintenance or repairs. Certainly for the first several years, the maintenance and repair costs will be significantly less than on an old parking structure, but it's not very long after you build your new parking structure that you're going to have to start spending money on maintenance and repairs, significant dollars. And what this means to me is that repair costs alone, absent of other factors, for an old parking structure rarely is justification for building a new parking structure. And then Anthony Kress's textbook on parking structures, it includes a survey that they conducted on the operating expense of 150 different parking structure operators throughout the United States. And they found that on average, and I adjusted the dollars to 2019 dollars, on average, parking structure operators were spending 41 cents per square foot per year. And note that the authors felt that that was not sufficient, or that was not enough money to be spending on the maintenance of parking structures. So remember the 41 cents. We'll get back to that. And then I included this slide here to give you a sense of the unit costs for different work items on concrete repair projects. And these are work items that commonly show up on WJE projects. Clearly, the unit cost will vary from job to job. It can depend on the size of the project, the quantity of the work item. Are you doing 1,000 square feet of column repairs, or are you doing 10 square feet of column repairs? The price can also depend on whether or not shoring is included in the unit cost for that work item, or is it included elsewhere, maybe in the general conditions or in an allowance. And then the location of the project and the bidding environment has a large impact on the repair costs. But you can see how a repair project can get rather expensive when concrete repair generally costs $100 a square foot for a full depth replacement, and you're replacing miles of sealant in your parking structure at $6 per foot. So I talked about the theoretical deterioration curves, new construction costs, and how much people are spending on their parking structures. But now let's kind of put it back together. So I'll revisit the deterioration curves. The problem with the theoretical deterioration curves is they were conceptual. There was no numbers to go with them. Well, now we have an article, or we have numbers to go with it. In 2018, there was a good article in ICRI's Concrete Repair Bulletin. Yes, there's actually magazines about concrete repairs, and there's even engineers who read them. And anyways, this article finally merged kind of the hard numbers we discussed with the theoretical deterioration curves. The authors were able to plot the cumulative repair costs for 66 different parking structures, all located in the Midwest. It is clearly a limited data set, but I think it can be used as a reference for actual parking structure repair costs, what might be typical. And you can see one of their graphs from their article on the right. It shows the cumulative repair costs over time for various types of parking structures. And there is quite a bit of scatter in the data, but you can see that cumulative repair costs increase exponentially over time, which generally matches the deterioration curves. I took their research one step further. I just converted their numbers from cumulative repair costs to an annualized basis. And the shape of the curve stays the same. But from this, we can get a sense of what might be reasonable to spend on your parking structure for maintenance and repairs on a year-over-year basis. Clearly, you can spend more one year, less the next year, but when you average it out, you'll find that your parking structure maintenance costs are going to increase over time. And I don't think you're not going to escape the fact that you're going to have to spend money on your parking structures. There are a few key nuggets of information that we can pull from this research. Number one is that for the first 20 years, less than a quarter per square foot per year might be enough. And then number two, there's a marked increase in the annual repair cost by the time the parking structure is 30 years old. Budgeting about 50 cents per year per square foot is not unreasonable. And then you can see it goes up from there. And remember, these curves are for parking structures that have been maintained by what I think of as educated and proactive owners. So if you haven't touched your parking structure in 10 years, don't be surprised when your parking structure costs are significantly more. And potentially parking structures in more mild environments may cost less to maintain over the long term. We don't know for sure because the study that I'm relying on here was based on parking structures in the Midwest. And we do know that there's different exposure conditions throughout the country, but the parking structures are also built a little bit differently throughout the country. They're detailed a little bit differently. All right, so let's step back to the cumulative repair cost graph. I think this is a worthwhile exercise to plot your parking structure on this graph. Take your cumulative repair costs over time and divide it by the size of your parking structure and see where you fall. If you plot well below the curve, that's represented by this blue dot, I think it could mean two things. First, it could mean that you've been doing a good job taking care of your parking structure, you've been proactive, and your maintenance costs are tending to be less than typical. Or it could mean that your bill is coming due. Eventually, you're going to have to spend money to repair and restore your parking structure. And then what if you plot way above the curve? That's represented by this red dot. I think this can be an indication, and I've been involved in parking structures where this is the case, where my recommended repair program alone, without even considering what's previously been spent, plots well above the curve. And I think that's due to, sadly, a lack of maintenance or having not spent sufficient money prior. So what do you do if you find yourself facing, the $5 million repair project you never saw coming? These are some of the common questions that we get. Often it's, why not just build a new garage? And as I discussed earlier, parking structure replacement costs are often significantly more than a repair cost. And then where do you park the cars in the meantime? And other factors. So that can be that's a big project to decide to build a new parking structure. And then occasionally we get ask, well, we just repaired this area. Why are there so many repairs again? And I think it's naive to think that you're done working on the project or on the parking structure once you finish a repair project. And also, that repair project was 5 years ago. Time flies. And typically, once the chlorides are present and corrosion has started, there will need to be periodic repairs for the life of the structure. Certainly, we can slow down the deterioration. We can start to space out our repairs. But as the graphs show, the repair costs, they don't stop. And then, can I keep using my parking structure? It's pretty typical for parking structure repair projects for them to be phased and for the contractors to actually have a line item in their contract for temporary facilities and traffic maintenance and barricades. And then, can I defer my repairs? Yes, often you can defer repairs, but understand that during the time you're deferring repairs, that corrosion, that deterioration, it's progressing. So you should expect to your repair quantities to grow if you're going to hold off on a repair project. And then in some cases, the repairs or at least shoring needs to be installed or performed immediately. So that's what I have to present today. I'll turn it over to Jim Donnelly.
Thank you, Andrew. I'm Jim Donnelly. I'm with WJE's headquarters in Northbrook, Illinois. What is maintenance and how often should we do it? There's 3 professional organizations in the United States that have pretty good documents that kind of summarize the various different maintenance activities that should be done in a parking structure, including documents from American Concrete Institute, Precast, Pre-Stressed Concrete Institute, and the National Parking Association / Parking Consultants Council. Those should be commonly available. Each of them has a nice little table itemizing a number of different maintenance activities, and they provide recommended frequencies for each of those activities. Another good source can be if WJ was involved in a previous large repair project at that facility. There may also be a project-specific maintenance manual that we would have prepared that basically took the information from those 3 commonly available documents and made them specific and unique to the particular parking structure that we were dealing with. So those various different maintenance activities, they tend to break down into 3 different categories. Non-structural items, and that includes a lot of the day-to-day stuff that gets done by the typical parking structure operator, including cleaning, making sure the parking control equipment is working, making sure the lighting's working, any elevators or HVAC equipment, making sure that stuff is working and keeping that up to date. One of the more important parts in that in the cleaning operation can be power washing down the parking deck and floors. Those documents that I showed you before, they generally recommend that all parking decks get washed down on an annual basis. And the reason for that is dirt and debris can build up on parking structure areas and hold water against the structure, and you can lead to deterioration in those areas. That's particularly true in northern climates where de-icing salts might be mixed in with that, and without cleaning the deck top surface, you might have de-icing salts left there for a longer period of time, allowing them to penetrate into the concrete and initiate the corrosion process. So generally that gets recommended to be done in the spring. Now, Tracy was telling you earlier about a number of different deterioration mechanisms. And all those deterioration mechanisms, water plays a role. And as a result, the control of moisture and water in a parking structure gets to be pretty important. So the waterproofing items are important. The plumbing obviously is the fastest way to take care of any moisture on the deck surface. So inspecting and cleaning the drains semi-annually is a good idea, and repairing drains as needed when they are no longer functioning properly. Now, waterproofing items are also important. It's interesting to note that the waterproofing items are usually, that you see in a parking structure, those ones are usually covered by a warranty. So sometimes, and a lot of times those warranties are on the order of 5 years or longer. So sometimes it's a good idea to perform an assessment of those waterproofing items like at 4.5 years before the warranty runs out, and then you get repairs to those items addressed during the warranty period. And again, those items generally consist of sealant, expansion joint seals, and any type of traffic coating. And it's generally recommended that stuff gets inspected semi-annually and basically repaired on an as-needed basis. In terms of service life for those elements, we typically expect to see about 5 to 10 years for the joint sealants. Penetrating sealers, maybe 3 to 7 years, or sometimes longer, depending on the penetration that gets. Expansion joint seals and traffic coatings, you're usually talking 8 to 10, 8 to 12, 8 to 15 years for those types of products. Again, all that stuff depends on wear, exposure, and the kind of the surface environment that they're in. Now, structural items are perhaps the third category, if you will, of maintenance items. We would expect, and those documents that I mentioned before are generally talking about checking for surface deterioration on at least an annual basis, particularly on older structures, and also going around, and if loose concrete is visible, removing that loose concrete on an annual basis. A more detailed investigation is recommended by those documents generally on a 3 to 5 years, and the recommended frequency kind of depends on the age, the condition, and the construction of the parking structure, so it will vary. A younger structure is not going to need as frequent of an inspection as an older structure. But when the engineer performs that, they can come up with a list of repairs and recommendations for when those repairs should be implemented. Typically, in a parking structure, we expect to see some sort of repair project every 5 to 10 years, but it can also be addressed on an annual basis if that works out better from a budgetary standpoint. So to look at some different maintenance approaches and the effective maintenances, I know we looked at a lot of theoretical curves from Andrew before, but we actually have some case studies that can show the impact of maintenance on the performance, the long-term service life of a parking structure. So case study number one, it's currently a 50-year-old parking structure located in Midwestern city. It's 6 stories tall. It's a fairly good sized garage, has over 800 parking spaces. If you use the information that Andrew provided previously, the replacement cost for this structure would be on the order of $20 million. Now, in 1992, the ownership of this garage changed hands, and the new owner, there was large areas of deterioration on levels 2 and 3 of the floor slab, and they wanted to know how best to address it. So they had WJ perform a detailed condition survey. And there's a few things that came out of the detailed condition survey. One is they had a lot of corrosion from exposure to de-icing salts, particularly on levels 2 and 3. And the condition of the garage got better as you went up in the structure. So that definitely says that the de-icing salts were coming from cars bringing in off the streets. We also could tell that the previous owner had done little to no maintenance. There were basically no evidence of repairs, no waterproofing to control the salts that might get brought into the concrete. As a result, our findings recommended $2 million worth of repair, including concrete repairs and waterproofing, and that was back in $1992. So the owner did not have $2 million set aside to spend on garage repairs. So instead, they decided that they would proceed to address this condition through a series of annual repair projects. What they ended up doing was basically budgeting about $200,000 each year. And the way we would approach it was WJ would select the worst area. And in that worst area, we would aggressively do everything we could to repair the structure and put it in as good condition as possible. All concrete repairs would get performed. In places where the rebar was heavily corroded, we would remove that rebar and put in new epoxy-coated rebar. And once all the concrete repairs were done, we would cover the entire area with a new waterproofing membrane to keep any additional de-icing salts out of the concrete. So that went on through about 2006. And at that point in time, that they had done all the repairs up to a portion of level 6. And then some additional repairs were performed in 2009, 10, and 11, and again in 2017. So overall, if you add up all those annual programs and the additional work that was done subsequent to that, the total cost of the repairs is about $4 million, which sounds like a lot of money, right? Absolutely. But if you spread it out over those 27 years, that's only about $150,000 annual average. Considering the poor condition that the structure was in 1992, and considering the parking structure is now in better condition than it was back then, I mean, that really indicates that money was pretty well spent. Now, there is some ongoing work that needs to be done to keep the condition of the structure up, but I think this owner has done a great job in taking a structure that was not in great condition and getting a lot of extra service life out of it. I mean, if you look at it now, considering that it's in better condition now than it was when they took it over, they probably bought themselves 10 to 20 additional years of service life just because of the differences in the condition. Plus, they've added the additional 27 years of service life just from when we started this program. So you can argue easily that you've added 40 years of service life to this parking structure with the program that they instituted. Case study 2, constructed in 1972. It's a precast concrete structure in a downtown location in a Midwestern city. It's a little bit smaller than the last one, a little smaller footprint, 124 feet by 188 feet overall, 300 plus parking spaces. So this structure, we got involved with this structure back in 1993. The owner had begun to see some deterioration, and he contacted a local engineer. The local engineer told him, well, you got a little bit of deterioration, and the structure is 20 years old, so that's about the service life for a parking structure. You just tear it down. Well, you guys know in an urban environment, the cost of tearing something down and replacing something can be well above the average. And the owner didn't want to take a 20-year-old asset that they'd spent significant amount of money on 20 years ago to build it and just tear it down and build a new one. So they got WJE involved, and we did a condition survey, and we basically helped them do repair projects in 1993, 1998, and again in 2004. And then after that, they instituted a more regular annual basis repairs. So those 1993, 1998, and 2004 projects were a little bit bigger, but now they're basically doing maybe $150,000 to $200,000 a year. And right now, it's in better condition now than it was in 1993. And so immediately, you can easily draw the conclusion that they've added more than 26 years of service life. Now, the annual repairs typically cost around $200,000. And the way we did it was kind of like on that case study 1. We focused on the worst areas, repaired the garage floor system, replaced rebar where it was heavily corroded. And when we completed the repairs, we put some sort of protection on the system, a traffic coating over the entire repaired area. So case study number 3. Now, all 3 of these structures were built right around 1970. So the state of the art of the construction has improved since then. But it also indicates, provides a good comparison between maintenance and what you can do with the structure and an unmaintained structure. This third one, it's basically a 2-story structure, one supported story above a slab on grade. The supported story is made out of a 2-way post-tension concrete slab located in a Midwest suburb. It's outside of an apartment building, so the residential parking there. So basically somebody comes in and out mostly, once or twice a day. The big catch here is, though, that there had been really no significant repairs performed over the life of the structure when WJE got involved in 2017. In other words, the structure was over 45 years old at that point in time, and little to no maintenance had been done at that time. The maintenance basically was limited to filling of potholes, sometimes using asphalt. And so when we did our condition survey, we found widespread distress of the post-tensioning system. At the places where the potholes have been filled in with asphalt, you could see completely failed tendons. Failed tendons were sticking out of the bottom of the slab in a number of areas. Wide cracks were located over the columns in the midspan, indicating possible structural issues. Excessive deck deflection, also indicating potential structures. We also did some analysis on this and discovered that the loss of post-tensioning system was significant. Now, our inspection openings identified 75% of the post-tensioning was likely failed in the south half of the garage, and 33% was failed in the north half of the garage. Plus, we had concrete deterioration at the anchorages where some of the other tendons that were still in good condition, I use that term good condition, they were still holding force. All the tendons in this structure had some sort of corrosion on them, so it was just a matter of time till the additional tendons would fail. So also note that there's, in a post-tension structure, sometimes you have a small amount of deck delamination, but a significant amount of deterioration. Because when we did a delamination survey, we only found about 7% of the deck was delaminated. So based on our analysis and based on the amount of tenants we lost, there's an immediate load restriction put on the garage. Shoring was installed in order just for them to be able to continue to use the garage. Based on our findings and the amount of work that would need to be taken to bring the structure back up to a good condition, we estimate a cost of about $4.8 million. And then using Andrew's numbers, the replacement cost is on the order of $4.1 million. So this is an instance where if they had done some maintenance over the time, maybe they wouldn't need the extensive repairs that they needed at the end of that 47-year service life.
Thanks, Jim. I'll summarize what we discussed during this presentation, and then also what we hope you remember from today. We know that parking structures have a hard life. They're exposed to perhaps the most severe conditions of any type of building. They're getting wet, they're getting exposed to big temperature swings, vehicles are bringing in chlorides, and some are exposed to freezing and thawing cycles. So invariably, they're going to deteriorate over time. The main sources of deterioration are corrosion, particularly from the chlorides, whether that's airborne in coastal areas or de-icing salts. And then we have freeze-thaw cycling. And all of these deterioration mechanisms are associated with water exposure. So if we keep water off our structures, we can do good to extend our service lives and minimize repairs. Regular cleaning helps as well. And then preventative maintenance is a good idea and a great way to prolong the structure's service life, particularly if we're doing high quality repairs with durability enhancements. Then I'll draw your attention to the right side of the screen. The table here gives you a sense of annual repair budgets you can anticipate based on the age of the structures. And again, it depends on how the parking structure has been treated so far. If you look back at case study 1, we still have maintenance costs a little less than shown here, even though the structure is already 50 years old. And then for case study 3, they're well above the projected annual costs. In this case is one of the few examples where the parking structure wasn't worth repairing. So good maintenance and regular maintenance is an important way to keep a structure functional and to extend its service life. And with that, we'll open up the floor to some questions.
Yep. As a reminder, if you do have a question, please type it into the Q&A box and hit send. And if we don't have time to get to your question during the call, Jim or Tracy or Andrew will follow up with you afterward. So now we can go ahead and take our first question. Does the warranty often require an annual washdown?
Yeah, so this is Tracy. Actually, Jim, did you want to jump in?
No, you got it. Go ahead.
Okay. So to address this question, there's a number of different warranties that can be implemented at the end of a parking garage repair project. I think the two biggest ones that usually get the most discussion, partly because they have the most cost implication, is the traffic coating or the waterproofing membrane and the expansion joint seal. And we've seen a variety of different ways that those warranties are written. So from a warranty standpoint, we have seen manufacturers and installers require that the owners follow the recommendations of the National Parking Association, which strongly recommends washdowns once or twice a year, depending on use and climate. However, just from an owner self-interest standpoint, because both of those systems are pretty significant investments, we do strongly recommend that the annual washdown be completed, mostly just to remove debris, because both of those systems, the expansion joint seals and the membranes, are subject to abrasion and physical damage, which is relatively high cost in the scale of things to address small areas. And it's a straightforward and kind of budget-friendly way to protect that investment.
Okay, next question. Do you recommend traffic coatings for precast garages? Andrew, would you like to answer that question?
Oh, yeah, I can address it. I was thinking Jim would, but we do from time to time recommend traffic coatings in precast parking structures, similar to the other parking structures. I don't know if Jim or Tracy wanted to add to that.
Well, a lot of times a traffic coating on a precast structure doesn't have a lot of benefit because a lot of times the critical reinforcing steel is down in the lower portion of the precast elements. The critical elements, the critical waterproofing parts of a precast structure are those joints. So one thing we have done with traffic coatings, we have put them in strips over the joints between adjacent double T beams. We've also put them in the pour strips over the inverted T beams and along the spandrel beams where there's small cast in place portions of precast decks. In cases where it's an older precast deck and there's a fully cast in place topping, we have put membranes over those. So it kind of depends on circumstances, but I think in some of the newer precast garages, it doesn't make sense to put a traffic coating over the, if you've got a 12-foot wide double T, maybe you only need a 2-foot wide strip instead of 12-foot wide section of coating over a double T.
Okay, next question. What is the average cost for a condition survey?
All right, so that's going to be pretty variable. We've done annual condition surveys for $10,000 or less. Right now, I've got a contract for a condition survey of a really large parking structure that's in poor condition. That's like $95,000. So now that's kind of extreme. Most of our condition surveys, we're talking 20, 30,000. It depends on if a significant amount of additional testing is required, because the main part of a condition survey really is getting your eyes on it. In other words, performing a visual survey and then doing a delamination survey of places where embedded reinforcing steel might be located and could be corroding. I don't know if Tracy, you want to add anything to that?
I'm sorry, Jim.
That's okay. That's okay.
Okay. Yeah, go ahead.
All right, Tracy, this next question is actually for you. What is the life expectancy for the various types of expansion joints?
In a high traffic area, it could actually be relatively short. A lot of times the warranty periods on those elements are about 5 years, which kind of gives you a good indication of what the manufacturer expects that service life to be. In lower traffic areas, we've actually seen them last 10, maybe 12 years, because there's a lot of movement at the expansion joint. That is the entire point of having an expansion joint, is for it to expand and contract. Those elements do get a lot of damage. Sometimes they're wide, they're subject to physical damage and wear. So for budgeting, we kind of go back where we started. Those are the ranges that we typically recommend for planning purposes, is high areas like retail, for instance, 5 years, residential, maybe closer to 10.
Okay, next question. Any tips, comments, or notes about structures or garages exposed to high temperatures, humidity, salty air, and stormwater, as in Florida?
So a place like Florida has all the ingredients necessary for corrosion to occur. You've got chlorides are present in the air just from airborne moisture coming in off the ocean or the Gulf. You have temperatures up in the Midwest. Corrosion reaction is actually shut down during the winter because the temperatures are too cold for the reaction to proceed. But Florida, that doesn't happen. So the corrosion reaction can proceed year round. So the big thing about that is, again, it probably should be approached in the same way. Is you really want to approach it to make sure your structure's in good condition and to provide the necessary protection for the structure. And in a newer structure, maybe you don't need to be as aggressive as putting a traffic coating down, but maybe something like a penetrating sealer, since that's a lot less expensive than a traffic coating. But in keeping your joints sealed, I mean, those are the main things you're going to want to do. And if concrete deterioration crops up, get it repaired in a reasonably quick manner.
Okay, Tracy, this question's for you. You mentioned earlier crack sealing lateral surface cracks and the relatively low cost involved. What about vertical sections such as subterranean garage walls?
Yeah, so for this, water is water, whether it's coming in from above, from the side, or from underground. In fact, sometimes underground can even be more aggressive if you've got certain chemical compositions getting attributed from the soil content. Typically during new construction, there's a number of ways to remediate that during design. I'm going to speculate that in this context, this is an in-service parking garage where there's maybe shrinkage cracks in the foundation and water's coming in, or there's insufficient waterproofing provided during that original construction. Sometimes the water is not a big significant issue as long as it can be controlled. The problem is whenever there's enough water coming in on a regular basis that it starts to cause delamination and deterioration of the walls themselves and the reinforcing in those walls. And in that case, typically we see a couple of different ways to mitigate that. The extreme one would actually be potentially excavating or waterproofing. That's usually a pretty unreasonable expectation. There are injection grouts and other options from the interior that can be used to successfully mediate that water. If not completely stop it, we're often able to minimize it to an extent that you can either buy yourself a lot of time or get it to where it's a controllable situation. And then all of those, it's definitely very project specific, and we would recommend having somebody come in who's familiar with those methods, take a look at the situation, and then discuss options and implications with the owner to make sure that there's a selection that is appropriate for this specific project.
Next question. How soon after construction should a traffic coating be added to a precast parking structure?
Well, this is kind of a follow-up question to what I was talking about before about traffic coatings on precast parking structures. In a brand new parking structure, you're talking about a fairly dense concrete with minimal reinforcing in the upper part of it. You could probably go a fairly long amount of time before you put a traffic coating down. The exceptions to that would be if there's a deterioration occurring, I should say, at the joints between different elements and at those pour strip locations. Those would be the locations where you might want to put a traffic coating in. I usually would probably try to delay putting a traffic coating on a double T structure, a precast structure, for 10, 15, 20 years and try to see if we can keep the structure in good condition just by maintaining the sealant. If we start having issues with that approach, then maybe go to something that's more aggressive like a traffic coating. Traffic coating is going to be more expensive than just sealing the joints. It's also going to require reapplication on a maybe 8 to 12 year basis depending on where and its location. So once you go to a traffic coating, it implies that you're going to have a fair amount of additional maintenance in the future. So as long as we can keep it handle the maintenance requirements with sealant work and maybe sealer work, penetrating sealer, I would probably try to do that first, and then maybe 10, 20 years down, look at the condition of it and see if a traffic coating is warranted.
Yeah, let me add just one thing to that, Jim, is there are specific instances of precast structures where you may have areas that have a little more cracking, particularly like pour strips. Sometimes we've had instances where installing a traffic coating on those specific areas shortly after construction is recommended because you get more bang for your buck in protecting those particular elements from water ingress in the cracks. And it's a more robust protection than trying to individually route and seal and then maintain that sealant on those individual locations.
Okay, next question. With 75% and 33% post-tensioning cable failure, what was holding that case study 3 deck up?
Tracy, you want to take a stab at that?
To be perfectly honest, I am not 100% sure. I think we've called it unquantifiable redundancies and friction. And I hate to be a little snarky about it, but that's one of those projects that actually freaked me out a little bit once I found out what I was getting into.
Yeah, typically a PT deck with a lot of corrosion, you get some binding of the cables just from the corrosion process. And that and a nominal amount of embedded reinforcing steel is usually what holds the stuff up. But our recommendations were to get the thing shored, particularly the side where we had 75% of the tendons out. So, but there was actually an interesting study done by the Posttensioning Institute on a parking structure that they demolished, and they basically cut all the tendons, and it didn't fail at that point in time. They actually had to still use explosive techniques to get the structure to come down. So sometimes I think the effects resulting from the pre-compression forces from the post-tensioning have positive effects that aren't fully understood or quantifiable.
Yeah, it also goes to attest to the significant safety factors that we like to use in civil and structural engineering in general. We don't want to count on them, but sometimes it literally saves lives.
Okay, that is all the time that we have for questions today. Thank you, Tracy. Thank you, Andrew and Jim. We'd like to thank all of you for joining us. We hope it's been educational. As a reminder, we will send you all a follow-up email with instructions on how to request credit for participation in today's webinar. And that follow-up email will also include a recording of the webinar for you to share with colleagues. So again, we really appreciate your time, and we hope you have a great rest of the day.